Go ahead, Jay.
Started.
I'm out of jokes.
No, you're not.
Knock, knock.
Talking about
My life is a joke.
I already made that joke.
Who's there?
No, wait, no, hold on, sorry. Why did little Susie fall off her swing
No.
Bad
I'm
joke.
not telling
No.
you.
Janik, apparently this is inappropriate.
Say,
No, it's not
Because little
inappropriate.
Susie has no arms. Knock, knock.
who's there?
Not Susie. Little Susie get
But she could kick the door.
Okay, anyway,
She
here.
used her
So that'll
head.
be big then.
She used her head.
Just
Let's,
kidding.
what does reciprocal mean? I spelled it wrong.
Isn't it-
Dang it, I knew it.
Isn't it opposite?
Isn't it
Reciprocal.
R-E-C-I-P-I-C-A-L.
Reciprocal.
Reciprocal. That's how you say it.
It's like,
I didn't know what it
if it's 3/1, the reciprocal, that's 1/3.
Well, I spelled it correctly by
Yes.
accident.
If it's 3/1, the reciprocal is 1/3.
But how do you
It's
say
like flipping a fraction.
Okay.
Or
And
even
then
if it's not, it's
if you
flipping.
multiply it, you get 1, right?
If you multiply an original by the reciprocal, you get 1.
Yeah.
Okay. This is going to be graphs of them, though. And I actually just learned how to do this. I was like, whoa, what are we doing? Like,
I'll be
You
damned.
didn't know how to do this?
well, I knew how to do it my way, but I didn't know this is easier, I think.
Oh.
I was like,
Alright.
Wait, can you show both ways?
okay.
To show you both.
So, for example, the graph of, you guys should know how to graph this, maybe. 1/x minus 2.
Yes.
Maybe.
See, what I would do normally would just be, I know what it looks like, and I know it's shifted to the right too.
Yes. And it can't touch.
1/x and then 1 just starts.
Right? So, but the way I just learned when I was reading this book, I was like, oh, that's cool, is they graph so this is the reciprocal. So what this book was doing, and I was like, I thought it was interesting, because that's how I roll, so I think math is interesting. They graphed y equals x minus 2 first, right? That's easy.
Yeah, it's just down 2. And then
Down
it's a straight
2, up 1 over 1, right? And the y-x-intercept would be 2, 2. Okay, so it'd be just like that, right?
Yeah.
And then, I don't know if they came up with this themselves, but they called it the big little principle. And it makes sense. It's basically says if a number is really big, its reciprocal is really small. And if a number is really small, its reciprocal is really big. Because if you think about it, like if you could give me a really big number.
3,007,200.
Yeah, that's what you said. Right? That's a big number. If I do the reciprocal of
It's
it,
1 over that.
that's really small, isn't it?
Yeah.
And if I take a really small number and I do the reciprocal of it, that's really big, isn't it?
Yeah.
If you 1 divided by a really, really small number, like 1 divided by 0.00004, it's 25,000.
That's a big number.
Big number. So then what they did, they said basically when you go to graph it, you can graph the easy part like this, and then use the idea of as a number gets really, really big, its reciprocal gets really, really small, and as a number gets really, really small, its reciprocal gets really, really big. Use that idea to graph this. And I was like, oh, that's interesting.
Still don't
I hate this
understand how.
talking camera. So I'm going to show you. I wish I could zoom out so I can get both on the screen.
You can lift it up.
Oh, yeah, that's right. Guys, they're going to go places.
Not with our
Not going to be your math effort.
Yeah. Our common sense will carry us far. Not our math.
All right, so basically, all of these y values for this line are going to get reciprocal, right?
Yes.
Not a word, don't use it.
Reciprocal.
They're all going to get flipped. Like, so, the easiest one to start with is right here. When y is 0,
X is 2.
we don't really
Wait, when y
care
is
about
0.
x. The domain, okay, watch. It would make probably more sense if I had made a table. Or we can just talk about it. Look at it. As we move to the right on this line, doesn't it get bigger and bigger and bigger and bigger and bigger and bigger?
Yes.
So as we move to the right on this graph, what's it
It
get?
gets smaller,
Smaller and smaller. Will it ever get negative?
No.
Yeah, no.
No, it would not touch the X.
You can have a negative.
It won't be negative because it's just you're gonna just do the reciprocals of all these. So like when you get this really, really big number way out here for y, you're on your reciprocal graph, it's just gonna be a really, really small number. It's never gonna go into the negatives, because it just gets flipped, it
But it'll
doesn't change the
get
sign.
really, really, really
So it's
close
just-
to zero.
It's gonna start somewhere, and, let's go here,
If you mean
1,
x
2.
can't equal 0.
And as you move out along, yeah, it's just gonna come down and go along the x-axis and get really, 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 really small, right?
So the reciprocal of a straight line can be a curved line?
Okay? So this is just, we're basically just taking these y values and flipping them. So like when x is 3, what's y on this?
3.
No.
3 minus 2, 1.
Oh yeah, 1.
3, 1, right?
That's what I meant.
In the reciprocal, when x is 3, what is y?
1.
Also 1. Because if you flip 1, you still get 1, right?
Yeah.
Yeah.
I see.
Wait,
I see.
the-
I should have done it a different way.
I see.
If I go to x is 4 here, what's the y value here?
2.
2.
So it'd be 2, 4.
So then on the reciprocal,
Maybe 1/2.
it would be a half. You'd flip the y.
And it
And
is-
if you use the formula, I was covering it up because I don't want you to just plug it in. I want you to just think, hey, when x is 4, y is 2. So on this one, when x is 4, y is half. You take the 2 and you flip it. It's a
So when
half.
you look, it is.
And if you look, it is. Anything you get for y here, it's just going to be 1 over that here, right?
Mhm.
Okay.
So what's going to happen right here when y equals 0?
Y is 0.
Well,
Nothing.
No.
Or let me, I could rephrase it, and I'll let you use the equation. When x is 2, what's y going to be on this one?
Nothing.
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 Nothing,
Because
Oh,
on this
that's what
one,
the asymptote is.
on this one, if you made it, I should have made 2. When x is 2, y is 0, right?
Yeah.
So on this one, when x is 2, we're going to flip it, we're going to do the reciprocal, 1 over 0. Can we do that?
No.
No, so what goes there? I think someone
Nothing.
just said it.
It's an asymptote.
Asymptote. And that's back to the beginning, what I said, I would have just shifted that to the right too, because,
Well, and you know
Yeah,
it's
that's what I would have.
and you know it's an asymptote because it's a 1 over x graph.
and think about this, as this line is getting really, really close to 0, aren't the y values right here getting really, 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 really small?
Yeah, so that should get big.
And so what's going to happen right here?
It's gonna move.
It's going to get really, really big, really big.
And there's no negative for this.
And then on this side,
Oh, there is? Oh,
Oh,
yeah.
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 these are really, 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 really small and negative y values, right? Small meaning
Almost positive.
close to 0.
Yeah.
So like negative 0.0001, negative 0.0002. So what's it going to be down here?
It's gonna go down.
Really negative.
Super negative.
Huh? What's wrong with that?
So there's, what you're saying is there's 3 parts of that graph that you're turning into the other graph?
3?
What?
Name the 3, Henry.
The one that's positive in between 2 dots and then negative.
Positive. Positive, yeah. It starts really, really small and gets big. So this is going to start really, really big and get small.
Couldn't you technically?
And then in the negative, it starts really, really small and gets, I don't want to say small, because small means technically,
it
yeah.
kind of like it's backwards for.
Yeah, it's backwards. It's really close to 0. Anything close to 0, if you do the reciprocal, it's going to create a big number. So like if you had negative
It's gonna be
.00004,
negative
it's going to be
2,000.
negative 25,000 or whatever it was.
Can't you just, like, for the 1 over x minus 2, can't you just, like, replot the points, kind of? Like, copy it?
Just make a table and,
No, like, copy the one that you already did, but flip it to the other side. I'm talking for the 1 over x minus 2.
oh, this?
Yeah.
Yeah, it's a reflection of this. But that's just for a simple one. So just using that idea,
Oh, wait.
What is that?
we're going to
principle
graph
called?
one without the equation.
Okay.
What's that principle called? The one.
They called it the big little principle.
Big little principle.
The little big planet.
Really, really big numbers, if you flip it, it's really, really small.
The little big.
Or is really
Little
big.
big.
And then really, really small numbers get really, really big.
Still stack people.
Did I
Give you an F, is that what you
the
did?
game?
So you just give me more time.
I got it.
They robbed my place.
Here's a graph.
Well,
How many rounds do you score?
Rob?
This
Reciprocal to that thing?
is f of x. We don't know the equation. It's just f of x.
okay.
We're going to graph the reciprocal just using the ideas we just talked about.
Which is 1.
Could that be piecewise function?
This?
Yeah?
I don't think so.
Yeah, I
That's
think
2 of them.
It could be.
Gonna be 3 different graphs?
I don't think it needs to be. I think you could do this in one shot.
I think.
I think I can
fall
do
below
one
me.
shot.
No, you'd have an x plus 4 on the bottom, an x plus 2 on the bottom. It'd be irrational. It'd be all crazy. You'd have an x plus 3 to the third on top. See?
No.
No.
I'm seeing.
The accent's
Because it's got a little shimmy and it goes through x minus
It's a
3.
loop-de-loop.
Oh, but that's right. We didn't perform so well on that last quiz we just took.
No, but no, I see what you're saying. It looks like a piecewise.
So we're in.
It could be.
Oh, that's one.
You can't do that.
It's not a piecewise?
No,
No,
he's
it
saying
could
you might
be.
be able to do it in one shot. It might be one equation.
I don't think it is. Because you can't do the reciprocal of a piecewise.
Oh yeah,
That would make, unless you did the reciprocal of all the pieces.
which was
Yeah.
stupid.
This is just a rational function. Don't care what the equation is. Here we go, let's graph this sucker.
The reciprocal or just like
Or the reciprocal, yes. This is the original, we're gonna graph the reciprocal. What do you think we should put on the graph first?
from
X
left
plus
to
4
right.
or something plus 2.
The
Oh,
asymptotes.
you all just said something different.
Asymptotes.
Asymptotes, that's what I was looking for.
Thanks, Adam.
Thanks, Adam.
Isn't that the plus 4? Plus 2?
This one,
Hey.
hey, hold on. This one has asymptotes at -4 and -2. That doesn't mean this one has asymptotes at -4 and -2.
So negative 1/2 and
Maybe
1/4.
positive 4?
Where will the reciprocal of this have vertical asymptotes?
-1 and -2.
Horizontal?
No.
Or would it be -1/4 and -1/2?
Remember, you take the y values from this one and you flip them, and that'll give you the y values for this
You
one.
plus
They don't have
2
a-
and plus 4.
Yeah.
What do you mean y?
What?
Zero.
No, you plug it in.
There's lots of y values.
2.
Here, let me ask you this. Let's start with something else. Let's start with the y-intercept. The y-intercept of this one is 2.
Okay.
What's the y-intercept of this
Negative.
No, it's 1/2.
one? 1/2. You just take all the y values and flip them. So 2 would be a half. So I don't know. I'm
So
gonna
you
go
take
y.
all the y values and put 1 over it.
Yeah, that's better. way of saying it.
Not that hard.
Makes more sense.
I thought flipping covered it, but. So the y-intercept will be a half, cool. So now let's go back to the asymptote question. Where do the asymptotes happen? Or, it's when y doesn't exist, right?
Yeah.
Well, what number can you flip and then it doesn't exist?
0?
0, because if you do 0, then you do 1/0.
Uh,
That doesn't exist, does it?
no.
So, what value of x would give us 1/0 on the reciprocal?
2?
When x is 2, y is like 2 point something, so that'd be 1/2 point something.
Negative half.
When x is -half, y is again
Oh.
2 point something.
I
So
thought you were taking
When
1.
x is
-2 and -4.
when x is -3, y is 0. On the reciprocal,
Oh.
when x is
a
-3,
third,
y will be 1/0
a third.
and not exist.
Yeah, totally, sure.
So the reciprocal is where the y-intercept is?
X-intercept.
Or,
What?
Yeah,
is
I
the
think so.
result?
The reciprocal means you just flip the
The
y values.
asymptote
Yeah,
is where
exactly, but it's
the,
usually.
The asymptote is where
Wherever
the
y
x-intercepts
equals
are.
Yeah.
Because that is where y equals 0.
Okay.
And when you do the reciprocal,
Gotcha.
y equals 0 will become 1/0, and it won't exist.
Okay, I'm with you.
Dig?
I
Okay,
dig dog.
okay.
insane. I'm gonna watch the video like
Okay.
10 times.
I mean, I was with him and I'm like, nah, dog.
Huh?
nothing.
I was with the
Just trying to figure out
I'm
what's
like, nah.
Let's think about what's going to happen where these, when x is I should have been a little more
When
consistent
x
here.
is -2, or no, y
When
is...
x doesn't exist,
So when x doesn't exist,
it becomes 0.
what do you think?
It probably.
We should do like,
One.
Becomes an intercept.
I think you guys need to visually see it.
Yes.
Original xy. When x is -2, y doesn't exist.
Because it's 0.
So
It's
in
1/0.
the reciprocal,
It would be 0.
because yeah, it's 1/0. So
0
if I flip 1/0, what do I get?
0 over 1.
which is
0.
What the?
So it becomes an x-intercept.
Okay, that makes sense.
No, yeah, I get that.
I don't,
I get that.
Go back a minute.
Do you understand what reciprocal means?
Yes.
Flip it over, or put 1 over it, right?
Yeah.
If this one doesn't exist, the only way you're going to get doesn't exist is if you have something divided by 0.
Now flip it.
Now flip it.
So 1 over 0 becomes 0 over 1, which is just 0.
Yes.
So it's 0 divided by 1.
Basically,
why at
this was
-2
1 over
there's a
0,
value
that's
for
why it
y.
didn't exist. So on this one, you're just going to flip, and it's going to be 0 over 1.
And that's also going to be one of the x-intercepts.
So why
Or that's going to be the,
Negative
yeah, that's the
x-intercept.
x-intercept now.
X-intercept now.
X
Yeah.
asymptote? Because it's 0.
Okay.
Okay, yeah, this makes sense.
So then for the -4 one,
When x is -4 on the original,
Zero.
y is 1 over 0 basically. So when I go to -4 in the reciprocal, I flip that and I'll get 0 over
so
1.
that's the other x-intercept.
Are there horizontal
Okay.
asymptotes?
See, this is okay.
So those asymptotes will always be your x-intercepts.
Of the
Is that
original.
true? That the asymptotes will like.
It's gonna be like that in every
Is
case.
that just flip? Yeah, because you're just flipping.
Oh,
Didn't hit the ground.
That was gonna be so cool.
So there's only one, so on the reciprocal, there's only one asymptote.
Wait, what? I'm actually curious.
For this
What's
one,
that
for this
about?
particular
For
one,
this
yeah.
particular one, there's only one asymptote
Because
because
there's
there's only one intersect.
Who?
X-intercept, yeah.
Okay, makes sense.
Wait, what about the ones that have the diagonal?
Slant asymptotes?
Yeah.
Are there horizontal asymptotes?
Oh, that's a tough one. I don't know.
We'll get there.
We'll get there, I guess. I don't think we will, actually. I don't think it comes up.
Yeah.
Because that's to get a slant asymptote, you have to start with a rational, and then you flip the whole thing. On all of these, we're going to start with like, oh, this one is starting with a rational.
This looks like fun.
I don't know, good question. I'm done. I haven't done it yet. Like I said, I just read this like 5 minutes ago.
Seriously?
Yeah.
Nice.
I was like, oh crap, Precalc, what are we doing?
Teacher,
Oh, this makes sense.
teacher appreciation week.
This makes sense. Bust it out. All right, so we're making progress.
Okay, we
Yeah,
have
pretty
we have that last one, I guess.
What time do we get out?
35? Okay.
We have the graph behind the asymptote of -4.
We need a graph behind the asymptote. Let's get this section over here.
Just use the principle of little big. Look
Just
at
use the principle of little big.
Look at the
Yes.
other ones, and that's going to tell you how they go.
The x-intercept turns into.
As on the original, as x approaches -infinity,
It gets huge, negative.
y approaches
Zero.
0.
Oh, other
So
way.
it'll
Oh,
go
negative
away
from
from
big.
0. on
Zero.
the
Should we write that down?
Yeah.
Yeah.
Yes, please.
Original. As x approaches -infinity, y approaches 0.
Zero.
Sixth period of one.
So then in the reciprocal,
It'll go
as
up.
x approaches -infinity, what's y going to approach? If you get really, really close to 0, if you
It's
get
gonna
really,
get
really
huge.
Far
small,
It's gonna
far
get
away from
huge.
0.
yeah, it's going to get really, really big.
It's gonna get
Because
huge.
you're going to flip it. The
Yeah.
little bit.
So it's going to go way up.
So as y approaches infinity,
Y approaches -infinity, or
as
x approaches -infinity, y is going to approach infinity.
infinity.
It's gonna
Yeah.
get
Because these get really, really small, like 0.00000 something.
Yeah.
So this is going to get really, really big.
Or wait, would it be? Oh yeah, okay.
So it's going to look like an x squared graph. then.
But would it
It's
be
just gonna
negative
go off
though?
and to the left high.
Because it's below 0. Who the?
Ooh, yeah, it would be negative.
So it'd go down, or it'd come
Yeah,
back
because these
up.
are all negative.
Yeah, so it'd be
It'd be a
opposite.
huge negative number.
Wouldn't it be opposite?
Yeah,
So it's going to go like this, down
Oh, that's
towards
interesting.
negative infinity.
yeah, right?
Yeah.
It's going to
I was
curve
trying to think of the curvingness.
down and to the left.
It'd be,
Right?
but then we have an x-intercept too.
I know what you're
The way that
talking
he
about.
wrote it,
No, what it looks like.
it's going this way.
But
Because it's getting really close to 0, negative.
but
so
there's
the
also
number's gonna be huge negative.
there's also an x-intercept.
Oh, the way that he wrote it is going this way.
Are there horizontal asymptotes?
No, it's not.
Yes,
Horizontal asymptotes
there is such a
on the
thing.
reciprocal?
Yeah, on this one, wouldn't that make
There's only
sense
one.
for it to?
Because don't you like flip it over that x line and dotted line? 1 over x.
Oh, because we're making a reciprocal of that one.
Say that again.
You know the thing where you make the line on the x, the diagonal line, and you flip the mirror it? Or is that?
That's inverse.
Oh,
We're not inversing. No.
okay.
We're reciprocaling.
Not a word.
Reciprocal.
Whoop-de-woos.
Would it ever? What graph's gonna intercept x, or is gonna hit -4 on the reciprocal?
See, this is crazy because we got it's really, really really, really big and negative. So that means it's going to get really, really small. on the reciprocal, right?
Yeah.
Yeah.
Then
Then it's gonna hit 0,
And then it's gonna.
and then it's gonna get really, really small again. Then it's gonna get really, really big and negative again. So what's gonna happen? It's really, really big and negative in the original, right here.
Well,
I should
aren't we
line these
doing
up.
that part? Are we doing the one right next to it? Because.
This is
The far left he's talking about. The far left.
Wow,
Isn't
that's
that-
almost like
Isn't
perfect.
that part we're doing right now?
No,
That part
we're
right
doing-
No, we're doing the far left one. The line to the
That,
left
right there.
of -4.
That's like legit
That dot is
scale.
-4, right?
I should just draw it.
Yep.
We're doing what's
So-
left of that.
There's not an x-intercept with that very last one.
Yeah, it wouldn't be an x-intercept, that's what I was saying. I was like, how is
So
it
that
gonna,
x-intercept is that first part of the extra third, right?
What do I mean?
So then
Because if,
So
The
far.
part I just drew is from this.
Okay, yeah, that's what I thought.
okay, I thought you were doing the back
I
half.
thought you were doing the left.
No, 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 before the, I
doing that,
drew those two.
Okay.
The top one starts really, really big and negative. So here it's gonna start really, really small and negative.
And then it's gonna get.
And then
really
it
big.
goes really, really,
As
it
it-
approaches really, really small and negative.
As it
So this is
approaches-
gonna approach really, really big.
Big.
As it approaches
And then the
negative,
one right
then
next to that's gonna go up towards
So then if I come over to this side, this one starts really, really big. If I'm moving to the left, this one starts really, really big and negative.
And it'll get
So it's
closer
gonna
to the-
start really, really small and negative. And then it approaches really, really small and negative.
Close to 0.
So it's gonna be like almost an upside down parabola. It might have some kind of weird, the answer's under here. It's gonna be some kind of weird thing like that.
but it's not gonna be like a parabola, but it's gonna be. You
It's
know,
gonna be like that.
Okay,
That
Is
makes
there
sense.
another way to teach this?
no, I like this one.
I'm not getting it.
I'm getting it, keep going.
I mean, you're doing a good job with.
You're doing a
You're
good
doing
job,
a good
bud.
job. You're very
You're
good.
just not understanding.
Holy crap.
You're doing a really good job. I have no idea what you're saying.
I'm gonna have to watch this video.
Okay, so it
Boom, when this thing hits 0,
This is the class.
doesn't exist.
doesn't exist.
Now we start.
It's really
Okay,
small.
this will be a lot less confusing now that we're not negative. Hopefully.
It starts off, it'll start off really big.
So
and
do you
then-
understand that this point right here lines up with this intercept?
Yeah.
It's really big.
Okay. This is really, really small right
It's
here.
gonna start off really big.
So this will start off really, really big,
Then it'll
right?
get super small.
And so
So it's gonna be like, shh. It's gonna go up like that.
Into
Um,
that line?
No, not touch it. It's an
It'll touch it.
asymptote.
It'll get close to
It's
it.
gonna be like, shh.
and
and
then
then-
it goes really, really small.
This gets really, really infinitely big, right? So that means this gets really, really, really small. And then it hits 0 because that's when the asymptote is.
Yes.
Yes.
Yeast.
Okay.
Okay.
We're starting
Now,
small.
this is really, really big again.
So it starts really
So which way is this gonna go after it hits this point?
Up.
Back up. It's gonna be small.
Wait, it starts off really, really big? When,
They're right here. I'm to the right of this asymptote
He's
now.
on the other one
Close
now.
to it.
Okay.
This is really,
oh
really
yeah,
big.
it starts off really big.
So
And
this
then-
one's gonna be really, really small.
So it gets
Yeah,
to
and then
And this
yeah.
one gets smaller and smaller and
Until it
smaller
hits 2.
until it hits there.
So
And then it gets bigger and bigger.
So it's
and
gonna
bigger.
rise
This
to-
one's gonna get bigger and bigger and bigger, and
So
then
it's
get
gonna go
smaller
like
and
that.
smaller and smaller.
It's like that.
So it's just gonna go.
And then
That's
is that
so
supposed to
weird.
be a 2?
What the salt?
So
That's half.
0?
Oh.
That's 0, 1/2.
which is the reciprocal of the other.
Oh.
Wait, is it ever gonna hit 0?
No, because 1 over anything is something,
Okay.
So it won't ever get.
but it won't get to 0.
So there is a horn.
Cannot be
Well,
No,
No.
kinda.
But not really because it hits 0 right there.
Okay, makes sense.
At negative
Move on,
2.
next lesson.
It is really great. Is 0 1/2 the reciprocal of the first line or something?
Yeah.
Yes.
Yes. Okay.
the only one.
If they gave us all of the y coordinates, it'd be really easy because we could just flip them all and then graph all the
So
flip.
these are reciprocals, not inverses.
These are
Yes.
reciprocals, not inverses.
Okay, so this is a completely brand new thing we haven't learned anything about yet.
Yes.
Yes.
Okay, that makes a lot more sense.
Welcome, Henry. Woo! We're not. You're not gonna start on something like this.
All right,
This
good.
was just to get the
No,
idea.
that was.
This is fun. Sure.
I
want the homework. Shut up, Isaiah.
just need to.
Oh, hey, look at that. I was kind of nervous. I almost wasn't going to show you if I was wrong.
No, we
Because like I said, I just read this 5 minutes ago, but there it is.
Attaboy.
Yeah.
I mean, the graph.
The five.
There's the reciprocal.
We can't actually craft it, he was a sketch.
Yeah, it's just a sketch. It's just like the ones we just did. They're just sketches. That to get the,
Attaboy. Give me some. Give me some. Boy.
I'll give you an air high five. But yeah, you're gonna say something.
You left me hanging for a solid 10 seconds.
Okay.
I feel like this is gonna be really confusing in the video, considering.
Yeah, this is one of those. You had to be there.
Who's missing?
What time did we get out? I don't even know.
35.
Graph.
So whoever's not here,
Graph.
Go.
What?
You said you're ready.
See, this is like.
we didn't. No,
This
who
is
said
like-
that?
Oh,
I
I
said it.
said it.
Whoa.
I said it, I'll take forever.
How'd you do that?
I wanted it.
Okay, well first we gotta do the original one.
This
which
is.
X
Remember the
minus-
toilet talk thing where it was like.
Oh
Oh,
yeah.
yeah.
John.
In math class we learned if John
2
had
plus
3
2 equals 4. The test.
John.
if Johnny had 3 apples and he took away 2, calculate the mass of the sun. That was in the toilet talk.
That's exactly what's happened.
I don't remember how to graph these
Well,
graph.
if you know the ratio between the size of an apple and the sun.
The size of the sun. You therefore calculate the purple kangaroo jumping distance.
Amazing how many people are absent. I've seen today.
If the sun's mass was the size of
You will know.
would there be a
This
singularity?
is what we just got done doing, the bottom part, you have to make it into the X.
So what we're going to do,
Is that one first?
this is the reciprocal.
So we have to graph what's on the bottom.
So what we're going to do first is graph the original.
I found that awesome.
Because we know how to graph the original.
Do we?
Which is X.
Those of us who participated in the quiz.
Oh, yeah, you have to factor it.
We can factor it, grouping,
Yeah.
pull out the x squared, that leaves x minus 1. Pull out a negative 1, that leaves x minus 1. So we go x squared minus 1 times x
Which can we
minus
factor?
1.
X squared minus 1 should be factored.
Which is x plus 1 times x minus 1 times
Boom.
x minus 1.
Boom.
Which is x plus 1 times x minus 1 squared.
Okay.
Boom.
So it's gonna bounce
I
off
didn't
of the-
follow that.
I just factored
Yeah.
that and simplified. Okay, so hey,
We know how to do that.
we know how to graph that.
So at -1, it goes through it,
So it's the x-intercepts are negative 1
and +1.
and positive
And
1.
it's gonna bounce off +1.
It's going to bounce off. Let's talk about end behavior first.
So there's.
So it's gonna
It's gonna
go.
be,
It's
it's
a
gonna
third.
go up, I mean down and up.
Down, then up.
Down, then up.
It's to the third.
And
So it's going to go down,
And then
come up,
And bounce off.
bounce off, go up.
boom. Okay, but now we have
Y-intercepts?
2.
Ooh.
No.
Look up here. It's easier.
That was the
One.
one from the quiz.
That is pretty much the one from the quiz. Yeah.
it looks
But the
like-
reciprocal of 1 is 1.
Okay, so now let's graph the reciprocal.
The reciprocal of 1 is 1.
I don't know how to do this stuff that's on the quiz.
You are not alone.
You see where I'm struggling?
Hawkins, like I see
Like,
what most of this
all of
class.
that?
Thanks a lot, Warden.
Welcome to college.
Welcome to college.
Warden.
Welcome to college. I'm giving you a preview of what college will be like. I'm just gonna keep hammering you guys.
just throw
And if you
crap
fall
at
behind,
keep hammering.
pretty soon you're like,
Wait,
I
Joe.
don't even know where I'm at.
What is life?
What is
Where must you
life?
take? What college is this?
Is this real life?
Is this
X-intercepts negative 1 and 1. Since that's squared, it's gonna bounce off. That was long. That was pre-spring break.
13 reasons what?
Yeah, I know, I knew how to do it back then. But I forgot how over spring break.
So now, coming to our reciprocal.
Let's
Let's check for understanding. Who's the ramp? Gamey. What's the y-intercept of our reciprocal?
One.
1. Yes, good answer. Good answer.
That's the first thing I'm
1. Because yeah, 1 over 1 is just 1.
Why?
All right.
I still don't know how to
The
graph
next
this
thing we
out.
can do is.
I want
asymptotes.
some. Yeah, I was just about to say I want to ask. Let's ask Juliana because she just looks like she's a deer in the headlights back there.
Yes, she is.
Where are the asymptotes for this one?
Is practice up?
Dude, I don't know.
Juliana,
Let's just assume it's 3.
asymptotes happen when it's like 1 over 0, right? When you can't get that number. So which values for y on this one, when you flip it and you put 1 over that number?
This will get zero.
Hint.
That was too many words.
That was.
Yeah.
I just realized that. I was like, I'm even getting lost.
I'm asking the question.
-1 and 1.
That's correct. Thank you, Bethany. What?
What?
You get it?
Don't.
The x-intercepts?
Look at the
On the
y.
original.
All of the y values. We're just gonna flip them over. So like, here, let's make a table of the points I know on this graph. I know 0, 1, I know -1, 0, and I know 1, 0.
And now, a word from our
We're gonna
sponsors.
do the reciprocal.
So going to the reciprocal, x's aren't gonna change. Y's are all just gonna get 1 over. 1 over 1 is just 1. 1 over 0. Boom, asymptote. 1 over 0. Boom, asymptote.
Snap.
Ow, my head.
Okay?
Could you just teach us that every x-intercept is going to be an asymptote?
Well, yeah, but you need to know why.
Well, you don't need to know
Some people
why.
don't just know that stuff.
Yeah, I have to know why I have it shows. I'm not-
The original x-intercepts are asymptotes. And the
Why
reciprocal.
does there go?
Yes.
Wait, so
You're
we
saying
got
this now, and then when you get to the quiz, you're crying about it.
We'll see.
Boom.
It happens every
I was gonna do it. Somebody had to say it.
Name's Juliana.
She can go here.
Yeah.
Just say-
Okay, so we got our asymptotes. Now we just gotta think.
She does have a point.
One of us is our mom.
Yeah, she is my mother.
You're
Yes, Jay.
okay. I was wondering how we got
Usually does
how we
have a
got
point.
those points on the original because I was writing it down and I didn't see it.
Well, I factored it.
Yeah, so you factored it and you get -1 because you do the
Those are the
opposite.
next intercepts.
Yeah, what'd you get the y-intercept from
From
the?
all the original or here.
dude.
Either one. Plug in 0 for x. You'll get 1.
Oh, sweet.
Okay,
Just making sure.
here.
I thought it.
This is always negative to the left of -1, right?
Yes.
So this one's always gonna be, the sign is never gonna change. Because 1 over a negative is still a negative.
But as it approaches that negative infinity, it's going to get really
Oh,
small.
I thought it was 38.
I said 35.
Oh, would you look at the text?
So that words can be like this.